I wanted to talk about safeties, overloads, things that are designed to protect the equipment. I don't think this comes up a ton with us, but it's always a principle that I want us to clearly understand. And the easiest thing to kind of start with is a float switch, because we all know how a condensate overflow switch or a float switch works, right? A float switch.
But most of us do.
Okay, the purpose of it is what? What's the purpose of a float switch?
To kill power to the system if the system has excessive water.
If the system is overflowing water, the purpose is to kill power to the system. So what does a switch do in order to shut off the flow of electricity, in order to keep something from working?
Great to open.
It opens, right? Yeah. Which is, again, for somebody who's really new, that kind of is confusing because you open a door to walk through it, you open a faucet to make water flow, but the easiest way to think of it is a drawbridge, right? You have if the bridge is closed, the cars can travel over it. If the bridge opens, the cars can't travel over it. So the way you draw a normally closed switch, meaning a switch that's closed during operation, during normal function, is like that. That's a closed float switch. That's when there's no water in it, right? But then when water enters, the switch opens. So as this level comes up, the switch opens, and then it looks like this, right? And that's because the water forced the switch open. Everybody buy that? Okay, so here's where I'm going with this. If you walk up to a system and it has an open float switch, you wouldn't just say, oh, well, it's a bad switch, replace the switch. Would you? What would you do?
Check to see if there's water.
You check to see if there's water in it, right? So you'd first see, is there an active cause? Why is it open? That'd be the first question. Well, and the assumption would be it's open because there's water in the float. That's what it's there to do. Everybody understands that. That's fairly obvious. But let's say you come up to a system and the float switch is open. You check it and there's no water in it. Now what do you say?
I was trying to cockroach in my float switch. It was actually lifting up the flow.
Was he just sitting in there and he was just doing it on purpose just to screw with you?
Yeah,
that kid's a character, man. Like, oh, I see you in there, you little knucklehead. You get out of there, you get out of there. It's kind of the relationship I have with the roaches in my house. I generally call them my children, but anyway, so if you come up to a float switch and there is no water in it, and the float switch is open, right? So it's here, there's no water. You check with an ohmmeter, it's not ringing out, there's no path, whatever. What would you do?
Failed switch.
You'd say it's a failed switch, right? But here's the trick to this question. If the switch is failed open, what likely happened when it failed open? It was open, right? Because a switch doesn't start closed, sit closed its whole life, just honky-dory, just sitting there, I'm closed, I'm closed, I'm closed, I'm closed, and then one day just be like, you know what, I'm gonna be open now, right? That doesn't happen. What happens is it opens, and then when it goes back to close, then it breaks, right? It's just like a door. It's like a door that nobody ever touches. Nobody's ever touched the door, nobody's ever tried to go in and out, and then all of a sudden it just falls off its hinges. Right? Not likely. It's more likely that you have teenagers in your house and they keep slamming the frickin' door all the time and then it falls off its hinges, right? That's much more likely. If a float switch fails open, it's likely that it's been going open and closed a lot. And if there's no water in it now, it's likely that there was water in it before. So the first thing you should do, if it's stuck open and it's broken, you gotta replace it, but try to figure out why. Odds are that the thing's been overflowing and just kind of consistently having an issue. Now that's actually not the best example, but I'm using it as an example because it's one that you can get your head around really easy, right? A float switch just doesn't fail open. So let's talk about some more common ones. And again, I just draw the symbols while I'm doing this because it helps you get used to seeing these symbols when you're looking at diagrams, and it just kind of helps you pick it up. It doesn't really matter to the story I'm telling, but let's talk about a thermal limit. Now, a thermal limit can sometimes be called an overload. That's what it's called typically with a motor. Or in the case of a gas furnace, or in the case of heat strips, it's just literally a thermal limit, a thermal shutoff. And what do you think a thermal shutoff is?
It opens.
Something gets too hot, it opens, right? Gets too hot, it shuts off. An example of this is when you put a surge protector on a piece of equipment. That surge protector, all modern surge protectors, are called TPMOV. MOV stands for metal oxide varistor. That's how a surge protector works. That's the technology. But the TP part is not toilet paper. It's not Halloween, okay? I know Bert was thinking that. No, it's thermally protected metal oxide varistor. And the reason that it does that, if you've ever seen some old photos of some of the older types of surge protectors, where there's like a big flame on the side of the house where it like melted the siding on the side of a house, that's what used to happen a lot with surge protectors is they would go into thermal runaway. It would start shunting current to ground, which is how they work when there's a lightning strike or something, but then they would get stuck doing that until the whole thing just melted down. A modern surge protector has a thermal limit in it, and this is how a thermal limit is drawn. It's normally closed, but then if it gets too hot, this is the symbol kind of for a thermal switch. If it gets too hot, then it forces the switch open. What are some common ones of these that you see? I just mentioned one, but what are some others?
High limit switch on a furnace.
High limit switch on a furnace, that's a good one.
Compressor.
Compressor overload, that's another one. Any others?
Heat strip.
Heat strip, yep. Could be, in some cases it's going to be a fusible link. A fusible link isn't drawn like this. A fusible link is drawn something like this, where it kind of goes like this. That's pretty bad drawing of it. But that's just kind of a standard fuse. And actually what's interesting is that even a circuit breaker is a version of this. Even a fuse is a version of this or this. It's just that with a fuse, when a fuse blows, it's done, right? It's one and done. Got to replace the fuse. So it's not just a switch opening, it just goes and breaks. I kind of liked how I did that. I like the noise I made too, and then it breaks. So in an old fuse box from a generation ago when they didn't have circuit breakers, every time a fuse would blow, you would have to go out to your circuit panel and you'd have to replace the fuse. Nowadays, it's like this. When that breaker overheats or has a magnetic overload, either way, it opens the circuit and then you have to reset it, right? But it's all the same philosophy. In most cases, circuit breakers are thermal, meaning they actually trip when they get too hot, which is why, coincidentally, you get more trips in circuit breakers on really hot days than on cooler days. If one of these does trip on you, you show up to a gas furnace and you have a high limit or a rollout. A rollout's another version of this, a rollout switch, and it's tripped or it's failed. It's open. What's the first thing you should think? Why? Why is it open? Not, oh, we need to get a new high limit, okay? Or we need to get a new fusible link. You may have to get that once you figure out why, but do everything you can to figure out why before you just replace a part, especially if we've got to come back. Because if we've got to come back, we want to come back and fix the entire problem. So let's talk about a high limit on a furnace, okay? High limit on a furnace is just inside the furnace, and if the air traveling through the furnace gets way too hot, it opens up, right? So what's a reason why it could get way too hot inside the furnace? Airflow. Airflow would be the number one reason. And what are some obvious things that you check when you have an airflow problem?
Filter.
Air filter?
Blower. Coil.
Blower, coil, right? Now somebody might say, well, that doesn't make any sense. On a gas furnace, the furnace is down here and the coil's up top.
It's trapped.
Exactly. If the coil's restricted above the furnace, that's also going to affect the airflow when it's in furnace mode, right? Because it's blocking the airflow through the furnace. So a lot of you don't think about that. Well, my heating airflow is also affected by a dirty evaporator coil, just the same as cooling airflow. You want to think through all of the causes. Let's talk about a compressor, because a compressor, thermal overload, same thing. Looks the same way on a diagram. What could cause a compressor to go out on thermal overload? Well, first off, what happens when a compressor is out on thermal overload? If that's open inside the compressor, what does the compressor do? Doesn't do anything, right? So you show up, and what do you find?
A hot compressor, 0 amps. You still have 240 going to your compressor, but 0 amps.
First thing you notice, though, when you walk up to the condenser is what?
Heat.
Probably not.
You can't hear it.
You're going to notice that the fan's running. It's not blowing any hot air out the top, and you can't hear the compressor. And that takes some perception. Somebody who's completely new or a customer, they're not going to perceive the difference because they still hear the sound of air, but you don't hear that deeper noise of the compressor running inside the unit. What are some reasons why a compressor could be out on thermal limit?
Dirty power
Can be.
in the villages.
Failed fan motor. Failed fan motor would be a big one. So if you walk up and you don't hear anything, you could have them both off because of a fan motor being failed. So you walk up, fan motor's off, and then you might every so often hear the compressor start running, and then it shuts off again. because it overheats because it doesn't have the fan motor to reject. Sometimes you'll have a compressor that's on temporary thermal limit just because it has a failed capacitor or a wiring issue. You know this because if you walk up to a system that has a failed capacitor, what will you often hear? Don't answer. Exactly here. Why doesn't it just go and then just melt?
Limits.
It's because the limit takes it out, right? Why does it do it so often? Because you'll notice it'll go and then 45 seconds, 60 seconds later, it'll try again. What's that? Say it again.
Resets.
It resets. Why does it reset so quick?
It's not as hot.
It's not as hot. The heat is isolated to the winding. And the winding is very thin copper wire. So it's an electrical overheat. That makes sense? It's an electrical overheat because it can't run. It's on what we call locked rotor. Compressor's bound up. And so it does this, like, no, I don't want to move. I thought that would be funnier. It wasn't. That was bad.
When doing maintenances, you barely bump the float switch. It'll cause it to run backwards and it'll overheat.
Yes, it can. Yep. Short cycling alone can sometimes cause it to overheat, right? But when it's isolated to the winding, it will reset more quickly. And you put the right capacitor in, now it's no longer locked. Now it can run. Now you don't have the thermal overload anymore. So you wouldn't want to go up to a system where the compressor's going, be like, oh, hey, it's going in thermal overload, need a new compressor. Thermal overload's inside the system, so just new compressor, right? Obviously you wouldn't do that. But let's say you go up to a system, fan motor's running, compressor's quiet, compressor has 0 amps. Now what do you do?
Cool it down.
Well,
Now you gotta check your hand.
you got to check to see if it's hot or not. So if that's the case, first thing I'm going to do is pull the quarter panel or side panel off. I'm going to inspect the electrical components and make sure that there's nothing obvious going on there. Check the capacitor, check the start gear, all that. Then I'm going to shut the power off, I'm going to pull the top, and then I'm going to just tap the compressor. I'm not going to put my hand on, oh my gosh, this is hot, my hand is melting. Not that kind of thing. Just tap it, see if it's hot. If it's hot to touch, what does that tell you? It's a fairly obvious thing.
It's hot.
It tells you that it's been running recently. It's not just failed, just magically since it stopped running last. It's been running. A compressor being hot is actually a good sign in terms of you being able to get it running again because it means that it has been running not long ago. It just got way too hot. What's the most common cause of a compressor getting way too hot?
No refrigerant.
No refrigerant or very little refrigerant. Insufficient refrigerant. But not insufficient refrigerant in the system necessarily. Insufficient refrigerant moving through the compressor. But what's another reason? There could be another cause that's actually the opposite.
Overcharged.
Could be overcharged. Could be way too much refrigerant. Could be a condenser coil that is completely packed full. The reality is the compressor gets real unhappy when it has poor compression ratio. High compression ratio, meaning that if the head pressure is way too high or if the suction pressure is way too low, both of those things make a compressor unhappy. And the worst case scenario is if the suction's way too low and the head pressure is way too high. Also, the temperature of the return gas can also affect it. So systems that have very high return gas superheats are going to be more likely to overheat with long run times. So those are all things that you would want to think about. What's the next step you have to take when you feel that hot compressor?
Cool it down.
Cool it down, right? Who has those Supco magnets with the hose that go on the hose? Only a couple of you anymore. They're pretty cool, right? You can hook the hose up, you stick it to the top of the compressor and just let it go. You don't have to run like super high flow rates, just trickle some water over it. Now some people will say, oh my goodness, you're gonna damage the compressor with that. It's in the rain all the time. The thing is designed to have water running over it. That's not a problem. Some people will say, well, yeah, but that shocks the compressor, whatever. Look, in real life, we've got to get this thing cooled down as quickly as we can because we got to figure out what's wrong with it to move on to the next call. The customer doesn't want you saying, all right, I'll come back 6 hours later and let you. It's one thing if you're working on a facility like a CubeSmart where you're going through maintenances, you find one overheating, well, then just shut it off and come back later. Right? That would be fine. Or if you're a facilities engineer and you've got a ton of units and it's not affecting the customer. But if you're there on a service call where you drove there and it's a residential customer, you need to get it cooled off. And the right way to do it is to run some water over it. Now, how do you know when it resets? What you can do is you can actually, and this is a trick that I think Eric Melly taught me. You take your meter, you put it on ohm scale with the ringer on, and you take it and you put it right on your contactor across the two legs. Now a lot of guys will be like, well, that won't work because it'll just ring all the time. Actually, generally your condenser fan motor, especially, well, because you probably have the top off anyway, but generally your condenser fan motor is high enough resistance that it won't make your meter ring, but your compressor windings are low enough resistance that as soon as it closes, they will start to ring. This is kind of a senior tech tip, because I always did it where I had to stick the meter down in there, but the problem is your leads aren't long enough, and now you're getting your meter wet, or you're running the risk of getting your meter wet. So if you keep it, we actually tested on the carrier units out here, and that is actually how it worked. Do you know that? Because you were there, weren't you?
No, Mike taught me that when I first started.
Really?
Mike taught me that too.
Yeah.
We yelled at him, he said it wasn't right.
Well, no, no. Well,
That won't work.
no. So
He described watching the resistance come down to a certain point, but
Yeah.
right, and there's that, but there's also diagnosing a compressor from up top. That's not what I'm suggesting, because I want you to visually inspect the terminals. That's not, so I'm not saying don't visually inspect. I'm just saying when you're waiting for it to reset, it's easier to keep your meter away from the water and have the ohmmeter hooked up and then just listen for it to start ringing than it is to have your meter down on the inside, down by the terminals. Do you guys get what I'm saying generally? Okay, this is kind of a complicated thing. But the point is that you figure out what caused it. You don't just cool down the compressor and say, all right, it's cooled down now it's working great. Could be dirty condenser, could be high head pressure because of overcharge, could be that it's low on refrigerant, could be metering device restriction, could be a line dryer restriction, anything that's causing either not enough refrigerant to make it back to the compressor, or too high a pressure leaving the compressor can cause that issue. Kind of like that motion there. It's like this or like this.
Good.
Like that. You know, we keep doing that? Yeah? Okay, good. Always figure out the cause. That's the point. Now, another type of safety. We have a low pressure switch. Looks like this. So that's what a pressure switch looks like. That's what a thermal switch looks like. And a float switch is just a circle, right? And then we have a high pressure switch. Do you distinguish that? Can you see the difference between these two? So this one here opens, the high pressure switch opens when the pressure increases. The low pressure switch, well, this is kind of, opens when the pressure decreases. Loss of charge switch, same way. Pressure decreases enough, opens, shuts off the system. So if you find a pressure switch that's stuck open, well, the first thing to figure out is it currently in that condition? You have a low pressure switch that's open, what's the first thing you do? Check your low pressure, see if it's way too low, and then maybe that's why it's open. But say you check it and it's not way too low. System's off, pressures are equalized, and they're what you would expect as far as standing pressure. You would say, yeah, the low pressure switch is keeping the system off, so I have a failed low pressure switch. First thing you check would be your connectors, check your wires, make sure they're not broken. But then at that point, you would jump out the low pressure switch and figure out why it went out on low pressure in the first place. Because it's probably low on charge or has a restriction or something that caused it to go off, because again, safeties don't fail in the opposite position for no reason. Just like a door doesn't fail if somebody didn't open it or close it or slam it. What are some things that would cause a high pressure switch to open? High pressure, failed condenser fan motor in which mode? So on a heat pump, in which mode?
Cool mode.
In cool mode. A failed condenser fan motor would cause a high pressure switch to open in cool mode. What's something that could cause a high pressure switch to open in heat mode?
Blower motor.
Blower motor. What else?
That's it.
That's the only thing.
Overcharge.
Overcharge. What else?
dirty filter.
Dirty filter. What else?
Failed ETX.
High pressure switch, pretty unlikely, and that goes into a complicated topic about restrictions and what happens when a system is restricted, but possible, unlikely. What else?
Failed ETX.
You just said the exact same thing twice. Evaporator coil dirty.
Failed TXV on a pool heater.
Can let's stop being like this. Low water flow on a pool heater, for sure. Now again, not a lot of systems have high pressure switches, but where's a place that we have a lot of high pressure switches that we do a lot of maintenances on, as in right now? Yeah, it's Vistakay. Vistakay does have high pressure switches. And if you were to find a system with a tripped high pressure switch right now, what would be a possible cause?
Running heat mode when it's warm outside.
Could be, could also be running in heat mode and there's some sort of indoor airflow issue. Indoor airflow issues in heat mode cause high pressure trips, because where's the condenser in heat mode? Inside, right? So now airflow over the inside coil results in high head pressure. Now it could be either way because it's switching back to cooler heat, so it could have tripped either direction. And one unique thing about Lennox is that it has this lockout. If it goes out so many times, the switch may even close again, but it still stays locked out. And that's where you pay attention to the board blinky board, right? Now, on Lennox, the most likely cause is what of a high pressure switch lockout trip on those Lennox heat pumps at Cassiola?
Well, condenser fan.
Condenser fan, right. Because those condenser fans, a lot of them are those older clamshell condenser fans that just don't last as long. And so then they'll intermittently work for a while, then they'll overheat and shut off. And if the condenser fan shuts off, the compressor may overheat, but it may just keep going out, and likely will keep going out on head pressure until that thing trips enough that it locks out, and you show up, turn it back on, and everything wores. Because now the condenser fan's cooled off again, now it runs again, you're like, I don't know what caused it. And then 2 o'clock in the morning we have to call again, it's doing the same thing. That Eli doesn't know anything, he looks like the Unabomber. I don't know why they always say that.
They do.
It's a weird thing that they always say. Don't send that guy back. All right, any questions about any of that? So lesson is, switch opens, it opens for a reason. Figure out what caused it to open before you replace it. And also, with thermal overloads, it takes a lot longer with the compressor, especially because of the thermal mass, when there was a refrigerant reason for it to overheat. A lot of times it takes a lot longer for that to reset than you would ever think. But if you walked up and it was hot, it will reset. So don't do the whole thing, well, I guess it just won't reset. It will reset. So just keep letting it cool until it does.
It will sometimes be cold to the touch on the outer shell.
And it could still be hot on the inside, yeah. I mean,
You gotta give it a couple minutes and it'll be all hot again.
You can have water inside the refrigerator.
right, you have to, so unhook the refrigerant pipes, spray water through the compressor. It's not funny, because it'll happen. Another thing that I wanted to mention quickly, because Sam said that you need to pinch off compressor stubs and braze them, how should you remove compressors and line dryers? What's the best way to do that? Cut them out. If you unsweat, you are likely to get a little fireball coming back at you. So it's a safety issue. But even more than that, with compressor stubs, you may or may not know this, but compressor stubs are generally copper-plated steel. And if you try to pinch them, a lot of times you're going to start breaking that copper plating off. And now when you try to braze it, regular braze rod isn't going to hold. Because regular FOS copper braze rod, the stuff we use all the time, whether it's 15% or 5 or 0, doesn't matter, it will not seal up steel. So now you're stuck with using 45% in a flux or using the flux-coated, really expensive rods. So it's better to cut it out. So now you've got a stub, a copper stub, pinch the copper stub, then braze that with your regular 15% or whatever you happen to have in your truck. Make sense? So leave a stub, pinch the stub, don't pinch the actual port on a compressor if you can help it. And if you are going to pinch the port on a compressor, because that's your only choice, then I would suggest just go ahead and just use the higher percentage silver. Even better would just be to go ahead and put a stub in it and then pinch it, then braze it. Great. Thank you all. Have a wonderful week.
Thanks for watching our video. If you enjoyed it and got something out of it, if you wouldn't mind hitting the thumbs up button to like the video, subscribe to the channel, and click the notifications bell to be notified when new videos come out. HVAC School is far more than a YouTube channel. You can find out more by going to hvacrschool.com, which is our website and hub for all of our content, including tech tips, videos, podcasts, and so much more. You can also subscribe to the podcast on any podcast app of your choosing. You can also join our Facebook group if you want to weigh in on the conversation yourself. Thanks again for watching.